Okay, in this tutorial we're going to have a look at linear polynomial functions. Okay, so really they're just our straight line equations. So remember, the equation of a straight line is given by y equals mx plus c. You might see that a lot of schools in America must use b, so you might see some other YouTube videos where they use y equals mx plus b. But either way, the coefficient of x, which is m, is our gradient or slope of our line. Okay, and our c value or b value, depending on your terminology, is our y-intercept. Now that never changes. Okay, now if we have a look at our gradient, because it's the one that's a little bit more interesting, okay, we can find our basic definition of our gradient, which you should remember from previous studies, is our gradient equals our rise over our run. Now rise is simply our y2 value minus our y1 value divided by x2 minus x1. Now what's really important to remember, okay, is if we're looking at a function like this, okay, and we've got two values here corresponding to two values there. Okay, x2 is the one that's always more positive, x1 is the one that's more negative. Now corresponding y values to go with it. Okay, doesn't necessarily mean that y2 will always be bigger than y1, because if we have the case of a negative gradient, okay, we do a similar thing. This is x2, okay, y2 is going to be down here, and x1, okay, gives us a y1 value that's bigger, and that's just going to mean here that the top gives you a negative value, okay, and that's fine because this is our positive gradient and this is our negative gradient. Okay, a couple of things to remember. If two lines are parallel, then the gradients must be the same. So m1 and m2, or the gradient of our first line and gradient of our second line, must be equal. If two lines are perpendicular, then m2 equals -1 on m1, and that's a really important one to remember. Okay, it's going to come up a lot because perpendicular lines come up a bit later on in the course as well. Now another one that we need to remember, it's easily overlooked, is that our gradient is also actually equal to tan theta. Okay, and this is how theta is defined. So it's defined as the angle between our line and the positive x-axis. Okay, so if our gradient is positive like this, our angle is going to be acute. Okay, if it's negative, it's going to be obtuse. Okay, it's a little sneaky one that comes up on the exam once every few years, so make sure that you are all over that. Okay, that's the main theory that we need to look at, but I've got a work example to do with you as well, okay, which I'll just grab. Okay, so we're looking at finding the equation of a straight line. So worked example here. Okay, so we're given a picture with a straight line where we go through the point -2 and the point 3. Okay, so we need to find the equation of the line and the angle it makes with the positive x-axis. That's what we're going to do in part A. So first of all, we need to do our rise over run. So we need to remember m equals y2 minus y1 over x2 minus x1. So we need to identify our x2 and x1 first. Well, x2 is the more positive one. So this point here is the point, really, I haven't written it all, but it's 3, 0. This point here is our 0, -2. Okay, so this one's more positive, so that's going to be our x2 value. It's going to be 3 minus our x1 value, which is 0. Okay, our y2 value is 0. Okay, take away our y1 value, which is -2. So we can see our double negatives are going to make that a positive over 3. So our gradient is simply 2 on 3. Okay, so we can really build our equation up here because we know we're going to use y equals mx plus c, where m is our gradient, so we know now that that is 2 on 3x, and c is our y-intercept, which we can read simply off our graph here, which is going to be, in fact, -2. So y equals 2 on 3x, take 2. Now, I've only answered the first part of this question. We actually want to find the angle as well, so I need to be careful. Remember that our angle is going to be in here. It's going to be theta. Right, remember that we've got the rule m equals tan theta. So that means that theta equals inverse tan of m. Okay, so we know now that theta will equal inverse tan of 2 on 3. Right, and that's going to give us a value of 33.69. I worked that one out before for us. Okay, now we've got a second part of our equation too, okay, which is find the equation of a line that's perpendicular to the given line, okay, and find the angle it makes with the positive x-axis. Okay, so if we're looking over here, right, the line we're looking for now comes through here. Okay. Sorry, I didn't actually specify that properly. Sorry, it was supposed to share the x-intercept. Okay, so we need to remember now with our second line that's perpendicular, m2 equals -1 on m1. Okay, really important one. So make this a lot easier. So m2 equals -1 on 2/3, okay, which means we're going to get -3 on 2. Okay. Thing that we haven't worked out though yet, okay, is what our y-intercept is. So we've got a little bit of work to do here. We're going to need to use our form of our equation, which I forgot to give you before. Y minus y1 equals mx minus x1. So I missed that in our theory. Good job, it came up here. Okay, this is a really, really useful form of finding the equation of a straight line, okay, because it involves using the gradient and one other point. Okay, now we just worked out what our gradient is. Okay, we know that's -3 on 2. We need another point x1 and y1. Now that's arbitrary. Don't think that it needs to be the same x1, y1 over here. We just need another point. Okay, now we actually know another point because it actually goes through this point here, which is 3, 0. So we know it goes through there. Now it's simply a case now of using our gradient and our two values in here. So we have y minus y1 is 0. Okay. M is this value here that we worked out, -3 on 2. X minus our 3. Okay. And then it's just a matter of rearranging and expanding our bracket. So often you need to move this value across. We don't need to worry because it's just 0. Okay, because it's -3 on 2 times x, okay, plus -3 times 3 on 2 will give us 9 on 2. Okay, so that would be the equation of our line that's perpendicular and goes through the same x-axis. Okay, so we wanted to, same point on the x-axis. So we want to go with that. Now we need to actually find our angle that makes too. So I'll just switch colours so we can see a little bit better here. Okay, so now we're looking at this angle in here. Now you would be correct in using our equation again of m equals tan theta, right, and doing this process and putting in this m value, but we know perpendicular lines meet at 90 degrees, so we can actually simply say that theta equals 90 plus 33.69, right, which is going to give us 123.69 degrees. Okay, so whilst we could have gone this process again, remembering that perpendicular means that they meet at right angles could save us a little bit of time. So, sorry I forgot to put this one in the theory, but make sure that you remember this form. Now hopefully, because we're into Year 12 methods, this stuff is really just a review. Okay, if you don't have a great handle on it, make sure you do, because there's some things that, yeah, will definitely come up on the exam. As I said, this one is a maybe, okay, but you'll often find some sort of linear equation on there at some point. Okay, that's it for this video.